Sorry, man, I had to change clothes. Made a mess down there. I knocked over a bunch of paint. Got it all over myself and whatnot. It's no big deal. Okay, all right. So, like I said, after I went down the basement there, you guys took a quick little break, whatever, reset or not. This is video 2 for today. So, I wanted to talk just real quickly about what I got you guys going on today. So, we watched the wolves. Went through the great explanation of mimicry and the whole explaining of the experiment that you saw. So now what I want to do here is activity 2 that you're going to do. And I like this activity because we're in that thought pattern of doing lots of interesting stuff and, you know, deep thinking about the why this, why that, and so on. So here's what we got. Okay, notice it says in small groups. Now listen real carefully. You can partner up with somebody in this class that you know, perfectly fine, all right? And do it together or by yourself. It can be done by yourself. If we normally would have done this in class together, that's why I said groups or pairs or so on. So if you partner up with somebody, I'll explain that first. Listen very carefully. It would be like, let's say that you guys follow directions, so you'll both submit the assignment. So if I have partner A and I'm B, on my assignment I'm going to write my partner's name and my name and submit it under my name. Then my partner will do the opposite too. They will submit their same assignment, okay, and have both of our names on too as well. So that way I know, same organism, same data, all that stuff that you guys partnered up, and it's going to be superb. But you don't have to. So, okay. So here's what you do, considering if you try that or not. All right. So you're going to choose an organism and then decide which adaptations make it uniquely suitable for surviving. Okay, those are big words. I don't talk like that. What do you mean, Myra? Okay, so I want you to think of whatever it might be, something real creative. You got the internet at your fingertips, okay? You know, how many times you go to the zoo and you see that organism that I can't pronounce because I butcher names and spelling and I'm horrible at it. But they're from far reach, some different country, but it kind of has a cattle-like look, or maybe it looks kind of like a giraffe-like structure, or an antelope, you know, but it looks like something you're familiar, but it has different, maybe a little different, you know, head or horns or ear or coloration, and it has this really fancy name to it. And you're thinking, me is what I want you to think about is, why does it look like that? What habitat does it occupy, or niche? Why there? Why? What has it done to earn that ability of fitness? Remember, fitness to survive and to reproduce. Okay, simple, basic. It's earned that right to 21st century. Right now, it's here. Okay, so this is what I want you to do. Think of a really cool animal, not like a dog, cat. It has feet. You know. Okay. Let's. You know. Come on. All right. And think past Wikipedia for Pete's sake, okay? So let's say, whatever it is, go with this really cool animal, all right? What you're going to do is you're going to think complete capacity, all of the anatomical and physiological solutions to its environmental challenge. What does that mean? Well, anatomical means what it looks like. Maybe its ears, where its eyes are located. How is its teeth? How is its jaw? Does it have a long neck, short neck? How is its coloration? And does its coloration, how does it fit into its environment? How are its legs or appendages? Does it walk on 2? Does it walk on 4? Does it jump? Does it climb? You get my picture. What I want you to do is start from head to toe or top to bottom, inside out of this thing, okay? Everything on these organisms are there for a reason, even if it's something very subtle. And I just want you to tell me. You don't have to write me a Gettysburg, la, 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 la. You can just say, it has this, and this is why, this is how it helps in this environment. This, boom. I mean, anything. And someone will ask me, how many features should we have? I don't know. Okay? There's a lot of things you're going to look. You're going to want to Google in something, your picture, and then you're going to read Wikipedia, and you're going to go, that was all I could find, Mark. That's not true. Think about it. Look at the picture. Think about where it's found in the world. What's the temperature? What's the climate? What other things are there? Okay? Hypothesize. I.e. example, the macaw. Caw-caw. The bird. You know the macaw, the big pretty birds, red, and you know they talk and all that, and you go to the pet stores. Really cool thing you probably would have never known about them, or you might know this. Obviously in tropical settings, they showed this one video, and I always remember, I thought it was really cool, that they were on the side of this kind of washed out embankment, looked like a giant clay side of a riverbank, and there was hundreds of them all flapping, and they were chewing, and it looked like they were chewing on the dirt. And the narrator said macaws, because they're such nuthatch, meaning type, they like to eat various different types of exotic nuts and various seeds and so on, and some of them have a high acidity level. They eat this mud, and it might have had a name on a certain river, I don't remember, it's irrelevant, but they eat the mud or the clay and swallow it, and it works like an antacid or like Pepto-Bismol or some type of coats and soothes, and it helps relax their stomach with the diet that they eat. I'm like, well, that's pretty cool. That's something that you would not get that unless you really look into. That would be something, you know, a physical thing that they do with their body that physiologically, you know, falls into place. So the physio is how do those things work? I.e. example, if you ever watched a cheetah, the fastest land animal, all right? No, I don't want to say, aha, I'm going to, because he gave us this example, all 18 of us, we're going to choose the cheetah. No, okay? So if you ever seen the cheetah run and watching how its spine flexes, pronates, and so on, and how it explodes with its, and it grips, and you see the claws. But one thing a lot of people don't realize in slow motion, how important its tail is to when it's cutting and gliding, and as it shifts, that tail is rigid and stiff, works the same way like a tightrope worker uses a beam to balance itself and its agility, the same way some of you are a lot quicker and more agile and can change directions and just light on your feet, okay? And it's an advantage for it in hunting purposes, okay? And you notice, if you ever seen a cheetah, how lean they are and how big barreled chest they are. Well, they need a lot of oxygen and they need a very strong diaphragm to insulate those lungs, and they need energy and bursts, you know, to catch the second fastest animal in their domain, called the impala. Isn't that funny? First, and I love that when people say the impala, it's the second fastest land animal. Well, cheetah's got to be able to run something now. You know, the impala can't be the fastest land animal. No, nothing would ever get caught. You know, so you think about it, I'm like, never thought of that. So, anyways, the physio is that part of the physiological, how things work, okay? So it's not just one of this and one of that. Think of everything. Take your time. You got a lot of time. I'm probably going to make it do, I think I might have put Tuesday, but I'll probably put it to Wednesday on the little work day and so on like that or whatever. I don't know. But it's not a difficult thing to do, but it's a fun one. You can draw me a picture if you want, if you're really artistic. You can cut and paste and put a picture on it, but either on a blank doc, you know, uploaded this and that. But have fun with it. I really like this one because and I like to see all the different cool organisms. You know, not that, you know, there's not a lot of them out there that are very common that have a lot of really cool attributes and stuff we overlook, but, you know, look into it. Probe deep, okay? Cover every X, Y, and Z 3D of it, okay? So that's what activity 2 is, okay? All right, so then you got okay, 20, okay, so then a little extra review. So there's activity 2, 24, 20. There's a little myth busters exercise there. I thought, you know, I always like myth, God, I can't even say it, myth busters, okay? Exercise there with a little thing. It's a short little exercise. It's one of the things that we would do if we were here in class type, so kind of creating that stuff for that. More review on getting you thinking, hypothesis, discovery base, lots of information. Ask us questions, which direction this go, falsifiable, true, false, valid, I don't know, all that stuff, okay? And then you got one here, introduction to experimental design, little video with an assignment, same type of stuff, more practice on that type of stuff, setting that stuff up. Another little video thing there like YouTube. And one more last thing there, parts of an experiment worksheet, and so on. And I'm in the process of working on like study guide because we're getting at the end of this unit. And at the end of this unit, so I'm working on the review guide type stuff for some part of next week. So those are the 4 things that you work on. The activity, that's activity 2. The Mythbusters activity, video design, experimental introduction to design, and parts of the experiment. Okay, so you got 4 simple activities between now and the next time I see you next week. Okay, so now I would have said, take a break, come back, at that 15 minutes before, and like I said, we're going to watch that. We're going to go right into that, so it's fresh in your brain. All right. The second part of the wolf in Yellowstone, but it's coming from one of the main biologists that was there and was introduced and was there from day one, and it gives you a different perspective, which is pretty cool. Okay. So right here and right here, and we're all fasten your seatbelts, because here we go. Don't worry, no howling, don't be scared.
It's early November, the start of winter here. As you can see, some snow on the mountains. We're beginning our annual winter study.
Uh-oh, computer. Okay. What happened? Oh, I lost power. No, I did. Yeah, I did. Okay. 2 seconds. Hold on. Dun, 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 dun. I left it unplugged. 1 second. Bring her all back up here. Okay. Boom. So I don't want to stop the video, and this was not planned. Oh, here it comes back. Just got to log back in and got power. All right. Okay, there he is. All right, let's start back over here. And 3, 2, 1, go.
It's early November, the start of winter here. As you can see, some snow on the mountains. We're beginning our annual winter study. I'm Doug Smith of the Yellowstone Wolf Project, and I've been here since the start, 1994. And so we're dealing with a decade of wolves being back in Yellowstone and the Northern Rockies. The things that we've been studying with wolves the last 10 years is a big one is their population dynamics. How well are wolves doing here? How well they survive? But we're also looking at how they interact with the prey, mainly the elk, but also deer and bison and moose and pronghorn and things like that, how that interaction goes. We've also been gathering data on what wolves do to the scavenger community. We've had 12 different scavenger species utilize wolf kills. In some ways, you can view a wolf kill more as a beginning than an ending, because so many animals use it, and we haven't even begun to look at the beetles and the insects that use kills.
Haha, tropic pyramids, decomposers.
Soil. All of those things are part of our studies here, and all of the answers that we're getting are interesting, some of them new. So kind of a cutting-edge research front that we're establishing here in Yellowstone with wolves because of the rare opportunity of them being so visible, having all of the packs radio collared and things like that. One of our first focuses in Yellowstone was how are wolves going to interact with elk, deer, moose, bison. And what we first did was we set up work in the wintertime. That's when most wolf studies are done, is the winter. And we looked at what wolves are killing, and we found that it was 90% elk. But they killed mostly calves and mostly old females, and at certain times of the year, bulls. They weren't killing this prime age segment of elk, the elk that have the most reproductive potential for the herd. In other words, the wolves were killing the animals that were most vulnerable. Now we've also found that the elk population has been declining since around the time of wolf reintroduction, and the big controversy is why. And many people think it's entirely due to wolves. We've found that this elk decline is due to many factors. We've been in the grips of a 6-year drought, and we found that that's had a big impact. We've also had human hunting pressure on elk that migrate outside the park. And we also have one of the largest suites of carnivores in any place in North America. Grizzly bears, black bears, coyotes, cougars, wolves, and humans. So these are all very important pieces of a puzzle that we're trying to put together as to how wolves fit back into this ecosystem. And we want to put real facts and real answers in the place of where people like to put myths.
Science, facts, imagine that.
What wolves are like and what they believe them to be like. We want to have factual information in place of those tall tales. all
I mean,
the
we don't
wolves
want to
that
assume
have
things?
any genetic
We
samples,
need science.
and we're able to kind of put together two separate world views of wolves, of what we learn about them in the field by tracking them, and then looking at that whole story that's written there in their genes, and knowing that information could be key in terms of how these individuals in packs interact with each other. If they're close kin, that could temper the interactions. If they're not, that could escalate them. And how we piece it together for that story and expand that to all the packs in the Yellowstone system will really be remarkable work. So that's in the future for us, something that we're looking at, which has been rarely done. It's been done with some wild dogs in Africa, some other places as well, but we want to do that here in Yellowstone. The last 10 years here have been remarkable. Literally nobody thought that the wolves in Yellowstone would be as visible as they are. For one, Yellowstone is easily the best place in the world to go to see wolves in the wild, and we're really happy about that. For a television culture where we learn about nature from TV, to have you be able to go out in the field, be with these wild animals, see what they do, endure the sleeping bouts and times when they're not doing anything, we think is important for our culture to be a part of. And we're very excited about the visibility of wolves. But it's also allowed us to look into the lives of wolves like no other study's been able to. Famous wolf researchers like Dave Meach say that we can learn more about wolves in a year here than what it took them a decade before. So what we've been able to learn is great, and we are very thankful to all the organizations and people that have made this possible. Wolves are back in the Northern Rockies, Yellowstone, because people wanted it. It's been a true team effort, and we just want to celebrate those 10 years. We hope the next 10 are as bright, and count our blessings that all the people, the conservation groups who made this happen, look what's been done. It's truly a remarkable thing in conservation and science and restoring nature. So what a time to celebrate.
Okay. Bam. How about that? Right? You got to see the things such as, I loved how he said, we gave the people what they wanted. Let's bring back the pretty wolves, but look how much more they got in return. And he talked about all the various, like the informational snowball of experimental design and hypothesis driven. You know, they talked about, looking at the genetics within the different packs, and how close they stay closer or wander outside in their actions. The fact about where, in today's where we assume something or we read something and we assume that has to be true. We spend weeks on trying to, show the factual side. By that time, the damage is done. And here's a scientist telling, the logic part, taking the time to get the full perspective. Like, everybody's like, oh, they're killing all the elk over time because I said, let us figure out that wasn't true. There was a 6-year drought. There was other predators. There were many factors that was contributing to that, but they think, oh, we introduced the wolves. That's got to be it. No, we need to step back and look at them and get a chance to look at the big perspective. So, and all of the avenues, and this was in 12 short years. This was 2007, roughly. Then this guy made this quick interview, 94 to 27, and now we're even another 15 years, 13 years later, how much more it's come back, and you see all the cool stuff. In fact, 4 or 5 years ago, we went on vacation, and we were going to Glacier National Park. They stopped, and they said, what was it? And they said, they named the pack, I don't remember, but it was passing across the valley. And of course, everybody was trying to get a glimpse of it, and we had one set of binoculars, and if you looked really far, they were clear off on a ridge below the tree line. You saw 1 or 2 little specks of the pack of however many there were, but it was cool just to go, whoa, I was in the press, of something like that. And like you said, right out there, hands-on, seeing everything and seeing how quickly everything kind of reset itself. And you saw a different perspective from not the smoke and mirrors and the cool movie stuff. No, and all the music, you actually saw a hands-on. And this stuff's going on all the time. So, you know, we always talk about, you know, the factual part of that stuff. And the nice thing about Science Now and stuff is doing that full-on, hypothesized-based, the if, and this, and testing it and seeing it and looking about, you know, what comes out of the data. What other things arise that when we have time, we can go this direction. And that's what he said. All the things that we see, how important one little thing is not a little thing in something as big and as beautiful as Yellowstone, which everybody's heard of. And you see, and everybody, wolves, and everybody's maybe seen something about, you know, somewhere, shape, or form, but this is how it started. And this is just one of many programs, okay? So I just wanted to end class, and this is where we would end class, and I would say, okay, you guys be safe, da-da-da, weekend, and all that kind of good stuff. But I hope you enjoyed those two different perspectives, and, you know, stop, watch again, or whatever, and don't be afraid to, you know, if there is something like that intrigue, or next time you see something, go, I wonder why, or how come, or think a little deeper about it than just the superficial stuff that maybe you see, or be a little more conscientious about, if you're an outdoorsy person and stuff, the impact you have when you go camping, when you go canoeing, when you go, you know, hiking, you know, when you go biking, you know, picking up your you know, the little things do help, you know, when you multiply on a larger scale and you see simple factors just in this hands-on experience, you know, how much it changes everything. So, on that, okay, that concludes today's class, okay? Thanks so much. You know, you got those 4 assignments. You watched a little short one talk, explain the hypothesis with the coral snake, king snake. Hope you enjoyed that a little bit. You can watch this part, and then, like I said, you could have took a break, but you would have worked on the assignments, then watched this video. It's probably in the 20-minute range or so on or whatnot. So, but anyways, all's well, so on. So, like I said, I will see all of you. This is by Friday, so I'll see all of you on Tuesday. If you have any problems, questions, concerns, or comments, you know how to get a hold of me. Send me an email or whatever it is. And if I don't, have a good, safe weekend. Okay? Watch out for bears. Wear your seatbelt. 10 until the steering wheel if you drive. Grill your food. Don't fry it or what's another thing? Bake it or grill it. It's always good for you. Brighter the berries, better for your immune system. Go easy on the side stuff like the condiments, like dressings and oils and croutons, all that stuff, and so on. Clean your room. Take your dog for a walk. I don't know. Mow the yard. Rake some leaves. I don't know. Anyway, all right. Good seeing you, literally, virtually here. So I hope all's well. But I'm going to go back down in the cellar and clean up my mess I made here real quick. So I will see all of you guys on Tuesday, all right? So I'm going to get out of here. Be good, be safe, and I'm out. All right, downstairs.